Everyone, I uploaded this video before, but there was a problem in the answer key and I had to change one question. So this is a re-upload and I hope anyone who's not seen this video, please do. So this is a question. I've combined two papers, GTA 2 and GTA 4, and yeah, let's get into it. The first question gives you this reaction, and if KCN is increased 4 times, then the rate of the reaction would be, so clearly this site is hindered. So because it's hindered, this would go through SN1 mechanism, which has order 1 and takes 2 steps, right? So the rate expression would be K times the substrate. Yeah, so it does not depend on KCN, so it would be unaffected. Here you can just see that delta U is equal to 0 for this cyclic process, and delta Q would be W and delta Q by T. So as work done in this case is negative, delta S would be negative, so it does not decrease internal energy. The entropy of the system increases, no, it's negative, delta S. Work net, yes, there is some net work done. Heat exchanged is 0, no, it's equal to the work. Sorry, wrong. So C should be the answer for this, A for this. Correct major product, this should be 3 by the way. Okay, so we have, this is a strong base, this would take this H, and yeah, this would make this major product through E2 or anti-elimination. Simple stuff. This is right, this is just Williamson ether synthesis, right? What about this? This is correct too. This is wrong, this is correct, this is correct. This is a normal question for HI, and this is pretty much right too. This is a plus M group, so yeah, para is major. About this one, the simple VSEPR theory does not explain the bent structures. So compounds like OF2 and ClO2, these won't be explained by it, and also ClO2, this would ClO2 minus, this would not be explained either, because this has pi bonds and pi bonds are not explained by VSEPR theory. So this this and this, so 1 second, yeah, so this should be the answer 3. About this, optically inactive stereoisomers, well, you would have one in E and one in Z, so 2. About this question, you can read this all. The question starts from here. The CCl2 attacks the phenoxide. This is the carbene CCl2. This attacks the phenoxide and makes the intermediate X. It's talking about the Riemann-Tiemann reaction, right? So this is the X intermediate. Then it is saying that phenoxide attacks to this. So what will be the Y intermediate and what will be the maximum degree of unsaturation of intermediate Y? So OPH 4 for this, which is 3 pi bonds and 1 for ring, and 4 here, 4 here, so 12 should be the answer for this question. Well, let's look at the A option. It would make this first, bromination. Then you have nitration. This would make NO2 as its major. Then Cl2. Okay, what do you need? You need 1 chloro, 2 bromo, and 4 nitrobenzene. And this would make this. So this is not right. What about B? B would make Br, then Cl. Then there would be a debate that who would apply a better plus M effect, right? Obviously the plus M would have this order, but this won't be the best for the synthesis, right? So yeah, we'll exclude B as well. Okay. What about C? C would first have chlorination, then nitration. Now you can have rumination here because this is meta for this, so this is a meta directing and this is an ortho para directing. So yeah, this would work and C would be the correct answer. What about C? Well, in C you would have this, then you would have Br here, and then you need NO2, and then again the same debate, plus M for both. So yeah, this won't be this would go through diazotization first. This is N2 plus Cl minus. Then your CuCl, well, Cu would get oxidized and this would get reduced. So when you reduce this N triple bond N plus this gets reduced into what? NH2. And is it a polar compound? Well, yes, it is. About this is a class 10th question, CCl4. This is not polar. About this, first you have reductive on ozonolysis, right? Then you have NaOY. NaOY is just another way of writing NaOH plus I2, and this is for what? This is iodoform test. This has iodoform, this has iodoform. This would work and both would form CHI3, and then there are other carboxylic salts, right? So this is the main thing, your yellow PPT for a positive iodoform test. So X should be CHI3 as it contains iodine. So yes, it is a polar compound. This is just a way of writing red hot iron tube. When you pass acetylene through it, you would get benzene, which is not polar. The net dipole is 0. Yeah, so this question, which of them gives positive iodoform test? This won't give, this won't give, this won't give, this would give from here, this can give, this can give, this can't give, and this can give. Yeah, this one, salicylic acid, this is what? This is your Reamer Tiemann reaction. This is Kolbe's reaction, and Kolbe's reaction does give you salicylic acid. Reamer Tiemann would just leave you with an aldehyde group here, right? It won't make the carboxylic group on this side. This would first make this, sorry, this would first make the orthobenzaldehyde, this the product of the Riemann-Tiemann reaction, and this other would be something like this, whatever, and then excuse me, then you would have oxidizing agent H2O2 and H2O, and this would make a carboxylic group, right? So yeah, this would form salicylic acid. This is desulfonation reaction. This would just make this. So C and D and B, correct. About this is a lot of data. You don't need to read this all because I've taken out the taken out the question which had a mistake in it, and yeah, it isn't in this video. About this, well, I'll tell you about each of the products. So moving backwards from E to the product given to us, this is C8H16 and E is some compound C8H12O. Well, when you compare the formulas of both of them, you would find that there is 4 hydrogens less and plus 1 oxygen, so there has to be 2 unsaturation points, and maybe a carbonyl would work. So when you look at all the data of the question, you would finally come to this conclusion that E should be something like this. Then you have been given that D goes through acidification, and uh, with heat it forms E. And well, E is still a cyclic compound. No, there is no information given on that. On the next part it is though. So E is clearly this, which right now this part is good. This is reflux with Na2CO3. Well, this would help in increasing rate for forward reaction for aldol condensation. Why? Because this is given to be acyclic, and where is it? This and another achiral. Wait, it isn't. A is acyclic and it forms B. So yeah, this won't make a ring, and neither would this. So yeah, it should remain acyclic. Now this makes a cyclic, so yeah, there has to be aldol condensation somewhere, right? So the heat would give you rate forward to be greater than rate backward, and yes, this would make a condition for the aldol condensation. Now analyzing our D product, you can clearly see that there must have been some organic compound right here. Like there is a bond like this, right? So there would have been something like this, and uh, this carbon would, yeah, there would have been some carbon which would have attacked here, and this would have gone here, right? So it must have been something like this, something like this. If you see, like this would have tautomerized. One second. And yeah, delta negative, delta positive, this would have formed this. So yeah, this is C. So C can be written like this. Now you've been given that A forms C when it is reacted with PCC reagent, which is the PCC. One second. Yeah. So okay. So basically, you would have Cr plus 6 to Cr plus 3, and yeah, this would go through reduction. This would be oxidized. So when you look at the structure of this, what was the structure of this? Let me check. The structure is C8H16O2, and for this it is C. One second. What is the? Is it given? Yeah, C8H14O2. C8H14O2. So clearly there is just uh, 2 more hydrogen in here. So you would just have some reduction of a branch of the this carbonyl, right? So you can just take one and you can reduce it and keep the other one same. So this would be your A. This is A. Okay. And when for B you would have H plus Cr2O72 minus. Again the same thing. This would go through oxidation, and well, it would, this is a good oxidizing agent, strong oxidizing agent actually. This would make you B. So yeah, that's it. We solved one paper for it. So you can clearly see this was unaffected. I discussed each part of this. This would go through E2, and yeah, it would form this. All others are major products only. This is due to the bent structure, one for E and one for Z. The carbene attached, this is X. Then you would have this to be Y. Maximum unsaturation would be 12. This one, clearly only this one makes the required thing. This first goes through diazotization, then CuCl reduces it, and you get NH2. This would be polar, this won't be polar. This would CHI3 would be polar, this won't be polar. This is very easy about this question. Yeah, pretty simple. And yeah, I hope you got this last question as well. Yeah, that's it. Thanks for watching.